back to business. Now look at that number line there. And oxygen in H2O2 is minus 1. Oxygen in H2O is minus 2. From minus 1 to minus 2, is it oxidized or reduced? Reduced. Reduced. So what it means that H2O2 is a reduced species, so it is oxidizing what? Agent. The question is, where is it acting as what? Reducing agent. So option A is wrong. Go to option B. It's still minus what? 1. Here is minus 2. Here is minus what? 2. In this reaction, option B, H2O2 also act as what? Oxidizing agent. Because here it has what? Reduced. Let's check the third option. Minus 1 minus what? 2. Here is also acting as what? Oxidizing agent. Because here it has what? Reduced. Definitely the answer should be D now, isn't it? Let's confirm it. Here is what? Minus 1. Oh, here is minus 2. Oh, here is minus 2. But this O here is the reason why it's now going to behave as what? Reducing agent. Because O here is what? 0. We'll check the number line again. Look at 0. Look at 0. Look at minus 1. Abi? So look at minus 1. Look at 0. So you are moving from minus 1 to 0. Is it oxidation or reduction? So that means H2O2 in the reaction has what? Oxidized. So therefore, H2O2 is acting as what? Reducing agent. So this is the correct answer. So here is minus 1. Here is 0. So it's changing from minus 1 to 0. It is what? Oxidized. Once a substance oxidized in a reaction, it behaves as what? Reducing agent. Correct answer is D. In another development, case 2 is also similar to this. I'm going to solve just 3 or 4 cases before I go to another thing. Now, right, H2O2, case 2, H2O, 2 molecules, plus 2F2 equals to, not equals to, arrow, okay, 4HF plus O2. Okay, I'm going to look at the question there. In the reaction above, right, in the reaction above, the substance that is being reduced is dash. The substance that is being reduced is dash. The substance that is being reduced is dash. Okay. The substance that is being reduced is dash. Okay, let me give you options. You know, I don't like giving options in this case. Let me give it to you. A, F2. F2. BHF. BHF. CO2. D, H2O. Answer is what? Can we check it? F is what here? 0. F is what here? Remember the rule now. Combined state of fluorine is what? -1. We'll check if it's F. Check if F has oxidized or reduced. From 0 to -1. Reduced. So because F is the, okay, that's the answer, F. They did not ask you, but in another development, I can still ask you, F2 is acting as what? Oxidizing agent. But in the reaction, the one that has reduced is what? F2. Then the one that has oxidized is what? H2O. How is it H2O? Why? because H is plus 1 here, O is minus 2 here, H is the same plus 1 here, so you may not know if you are to judge it with this man. But if you are to judge it with this man, O here is what? 0. So in the reaction here, H2O has what? Oxidized. Why? Because oxygen in O, H2O, has changed from minus 2 to 0. This one has changed from 0 to what? Minus 1. Case 3, finally. Okay. Okay, take the reaction down. Okay. Well, let's go. Right. In the reaction above. In the reaction above. In the reaction above. That the reaction. The reducing agent is question mark. I will not give you option. So you need to be taught how to answer even without option. So when you see option, it will not be a bonus to you. I will not give options. So the question says now, the reducing agent is what? And I want us to answer it as essay question, essay type, not MCQ, not as multi-choice question. I'd like us to answer it as theory question. Now, the question says, the reducing agent is question mark, and give reason why. Take it down. The reducing agent is question mark. Giving reason. Giving reason is 2 in 1 question. Giving reason for your answer. Question say the reducing agent is question mark. So when you state the reducing agent, you give reason for stating that whichever is a reducing agent, why it is a reducing agent. And well, I'll leave you. Yes. The reducing agent in the reaction is what? Silver in nitrate is what? Plus 1. Silver is a univalent ion, is a univalent metal. Okay, all on a group 1. Hey, how is it in group 1? I know that the element in group 1 are hydrogen, lithium. Okay, so you say, is this silver? Hey, Uncle Lonka, because you don't know that we have 2 group 1s in the periodic table. 2 group 1. That's why periodic table are in 2 blocks, A and what? B. And where group 1 A, where group 1 what? B. Group 2 A, group 2 B. Zinc belongs to group 2. But which are the group 2? Which are group 2? B. Is B. Silver is in group 2. Sorry, is in group 1 because it's a D block element. You know it's in D block. Okay, maybe D block or not. You don't know, you will know later. Okay, let's answer the question now. Silver is plus 1. Like you know, oxygen is minus 2. Nitrogen is what now? Plus 5. It will be very easy to find out the one in the middle. Ilmagonka, Maronka, Mazei Titi. So Netiti again plus 5. Make sure that the sum of union in neighbor is 0. Not by 6 mole, by a mole. Check it, it's 0 up here. Then 6, then 5. Add the anabo, on your 6. Olonka times yanka, I minus 6. Add the 2 of them, 0. Is a rule. Come do the same thing here. Do it here. This is what? Plus 1. Osoro and then nabo minus 1. Osoro. Okay, man, Osoro. Good. Hello? Yes. Hello? I'm fine, sir. Please, can I call you back? I'm in the class. I'll call you back once I'm done with the class. In the next 2 hours or 1 hour, 30 minutes. Okay. No. Also, minus 1. Minus 1, they know. And I think you know too. Okay, let's go here. What will now be the associated state of phosphorus? You should know now. Once you know this one, you should know the other one. Now, Omambo minus 1. Because you are multiplying by the atom here now, which gives you 3, Abi. So, phosphorus is what? Minus 3. Extend it to here. O is still minus 2. H is plus 1. Now, since silver now is alone here, silver is what? 0. Or now is it together? Or now is it concast in or? O can cast a quado. Nka quadro of ma. What a meaning? Or go to 0. Then, I check Nka. H here is still plus 1, Abi. O here still is what? Minus 2. Find P. Is what? Plus 5. H here is still plus 1. O here is still minus 2. Find N plus 5. If I get yellow gaka. Then they check Mohabo Gabo reducing agents. HNO3, PH3, H2O. Mari attack in the check. What was again at this side? Okay, this is what we are checking to know how to know whether each of every one of these will be reducing agents is what has been the effect of this here. Now for this AG here, it is now what? 0. For the fact it has now changed from 1 to 0, it's reduced. And because it reduced in the reaction, it is oxidizing. It will not be the answer. Shift to this man. Shift your attention now to this man. This is what? 3. Plus, okay, sorry, minus 3. Check what phosphorus has become this side now. Plus 5. Or reduce oxidizing. Because in the reaction, it is the only one that has oxidized in the reaction of clear. That is having changed from what? Minus 3 to plus 5. In this reaction, PH3 is acting as what? Reducing agent. Water does not act as anything. Water is a spectator. Do you know why water is a spectator? In this reaction, what species is a spectator? Spectator only clean doors and oxidize. They reduce. Nothing happened to it. Well, check it. H is what? Plus 1. Plus 1. Minus 2. Everybody for O is what? Minus 2. H this side hasn't changed this side. So it's the one that is what? A spectator. But this one changes to 5. This one changes to what? 0. This one is oxidizing agent as far as this reaction is concerned. Why this one is what? Reducing agent. The question now says, not only you know that PH3 is the reducing agent, of what reason is PH3 a reducing agent? What will be my reason now? Because its oxidation state has changed from minus 3 in pH3 to what? Plus 5 in H2PO4. H3PO what? 4. Please write it like that. Right. The reducing agent in the reaction above is pH3. The reducing agent in the reaction above. The reducing agent in the reaction above. The reducing agent in the reaction above is pH3. Is pH3. Come on. Because its oxidation number. Because its oxidation number. Its oxidation number has changed from minus 3. Has changed from minus 3 in pH3 from minus 3 in pH3 to plus 5 in H3 PO4. H3 PO4. Full stop. In the same reaction, continue. In the same reaction, A2NO3 AgNO3, Ag in the same reaction, continue. In the same reaction, AgNO3 acts as oxidizing agent. Act as oxidizing agent. Act as oxidizing agent because if oxidation number has changed from +1 in AgNO3 has changed from +1 in AgNO3 to 0 in metallic silver. To 0 in metallic silver. To 0 in what? Metallic silver. This last case question will be for you. I will not solve it, and I won't even attempt it. It's very simple. It's for all of you. I'll go to another thing I have for you today. Let's now to question. Right? This should be the case what now? Case what? Case 4. These cases are like examples, but I want to make it a case. So you fight a case, you win a case. Let's go. Which of the following equations? Which of the following equations? Which of the following equations? Equations. Which of the following equations represents an oxidizing action? Represents an oxidizing action. An oxidizing action of sulfur 4 oxide. An oxidizing action of what? Sulfur 4 oxide. You need an option to answer this one. So let's go. Right. Option A. Okay. Which of the reaction has shown that sulfur has oxidized? Oxidizing action of sulfur. Answer is what? Answer is B or D. Correct answer. Correct answer. D. How is it D? Okay, I'm blocking. Why is it D? Is it because it's oxidized or because it's reduced? You're not getting this thing though. It's because it's reduced. The one to ask you, which of the following is sulfur acting as oxidizing agents? That is oxidizing action. Linear now, sulfur here is what? +4. Do you know why it's +4? Now. Oxygen will always be -2 times by the 2 atoms beside the sulfur now. It gives you -4. So sulfur is +4. That's why it's sulfur 4 oxide. You check yellow sulfur and on the other side. You check when check it on the other side. Because you check you have a problem. Check it now. Asking where the sulfur 4 oxide is specific. Sulfur 4 oxide acts as what? Oxidizing agent. Now the sulfur 4 oxide itself is 4. Here is what? 0. Check other ones. Let's check other ones and see why this one cannot be the answer. Plus 4 plus 6. If you remember now, what do you see that happen here? Sulfur has oxidized, Abi. So in this reaction, sulfur is its action here is what? Reducing. Why is it reducing? Because it's what? Oxidized. Sulfur 2 here, plus 4 plus 6, the same thing. Sulfur here, plus 4 plus 6, the same thing. The only reaction in which sulfur show oxidizing ability is in option what? D, where it what? Change or reduce from plus 4 to what? 0. Reduce. So because it reduced, it shows oxidizing power or ability. Okay. Yes. Please find the oxidation state of Pb and S in the compound below. I'm a little confused. Okay, don't be confused. PbSO3. Who can help us with the name? Lead there has oxidation state of what? Plus 2. Now why is lead plus 2 in that reaction? To which group does lead belong periodically? Lead is which group? Lead is in lead is in group 4 now. Lead is in group 4. Lead is in the same group with carbon, silicon, germanium, tin, and then what? Lead. All the elements in that group shows 2 standard states of oxidation, which is plus 2 and plus 4. But as far as this question is concerned, the oxidation state of lead here is what? 2. 4. But before you know 4, lead is plus 2. Of course, you should know that oxygen will always be what? Minus 2. It's very simple to find sulfur now. Sulfur is what now? Sulfur is what? Plus 4. What can you name the compound? Lead 2 trioxosulfate 4. But we can see make mistake nearby 4. Keyoga Bozeketa. Sulfate 6. Both sulfate 6 and sulfate 3, both SO3 and SO4, both have the same valence of minus 2, minus 2. Have you seen why lead is plus 2? Have you seen why lead is plus 2? Because if I want to combine this with lead, why this is Pb 1 mole in the reaction, SO4 1, it means that their charges are equal. They cancel. But not actually the lead, the other aspect of lead, which is 4, which is 4. Are you with me now? Which is plus 4 here. Here it becomes plus 4. Here will still be 2. This is 0. And then put here plus 4 minus 2 or 0. Okay, all the equal to plus 2. It must be 0. Okay, you make it according to 0. Can one guy according to 0? Times CNK by 2. Times CNK by 4. 2 times plus 4. 4 times minus 2. Minus is now what? 0. This means that lead is what? 2. This is what? 4. Well, let's write the formula down. It becomes Pb2 bracket SO4 bracket what? 4. How will I name this? Lead 4 tetraoxosulfate 6. Well, that will cover that naming, special class of naming. All the knocker, each name ion, 2 ion oxides. How do you name this as? You know this is going to be minus 2 plus 2. You see how easy it is. How do you name this one? It's what? Ion 3 oxide. You can find the state of ion. You can say that ion is 2 what? X. Let's assume we don't know ion here. Plus how many atoms of O is there? 3. Times it by your state of ion of oxygen minus 2 equals to 0. 2x minus 6. Okay? Equals to 0. 2x equals to 0. This goes over equal what? Plus 6. 2x is plus 6. Have you? Divide both sides by what? 2 here, 2 here. X alone is what? 3. Ion 3. Oxide. The other one is what? Ion 2. You don't got it. That's how we think cancel because already 2 of them is equal to what? 0. Okay, now. Balancing redox or ionic equation. In redox reaction, right? In redox reaction, comma, electron, open bracket, write S, which it means electron or electrons. Electron, put S in brackets, is transferred from reducing agents to oxidizing agents full stop. Hence reactants and product particles are balanced atomically and ionically. In order to obey law of conservation of mass. In order to obey law of what? Conservation of mass. I think you know what that law is. What does it say? Matter can never be created nor destroyed. Name bigger create matter, name bigger destroy matter. When you write equation and the number of the mass of the reactants is equal to mass of products, you now know that matter has been created nor destroyed. But when the mass of reactant is equal to mass of products, you have what? Maintain law of what? Conservation of mass or matter. There are 4 chemical laws in chemistry. This is one of it. Law of conservation of mass, law of definite proportion or constant composition, law of what again? Multiple proportion, and law of reciprocal what? Proportion. 4 of them. Whatever name apply this particular one is in balancing chemical what? Equation. But this is according to Dalton's law. You know that matter can never be created nor destroyed. But some chemical reactions that this law cannot explain. Can you give me an example? Radioactivity, radioactive decay. Decay may you have created. Oh, you get bombard your nitrogen or carbon, or you get nitrogen. It destroys carbon. You know, we take carbon get a toy bomb. We do just destroy nucleus carbon. Then carbon 612. It destroy air by a moving charge particle or change it to what? Then you get change it to 7. Sorry. Oh, the carbon cause under other radioactive. Radioactive carbon is this one. I get one car radioisotope because they sorrow. If you make it it will bomb or decay, it creates an atom. If you make it creates again. What do you call these 2 elements? They are what? Isobar. They are what? Isobar. Isotope carbon. Isotope are atom of the same element that have the same proton and electron but different neutron. Chakwan can call loon. Chel can call loon something. Get nothing. Ntuno. Onya buchlorine. Onya bucachlorine. Onya can wait 35. 37. This phenomenon is called what? Isotopy. I said this phenomenon is called isotopy. Well, what is isotope? Atom of the same elements. What are they having in common? Let's check what they're having. Proton, electron, neutron. How many protons are here? 17. Remember what you put 17? This is atomic number. What atomic number? Number of protons. How many electrons are here? For the fact that an atom is chemically neutral, number of protons is the same as what? Electron. 17. How many neutrons are here? How many? 18. How many is in this one? 17. How many electrons in this one? 17. How many neutrons are here? 20. What is isotope? Atom of the same element, having the same proton and electron, but different what? Neutron. Or I say in isotope of 2 elements, what is common in isotope of 2 or more elements? Can you common about? They have the same proton, they have the same electron, they even have the same atomic what? Number. What? Can you add this? Can you find what's common between 2 of them? They have different mass and different neutrons. Yeah, well, I would take a multi-choice and do a pair gas. Okay, so which of the following are not common with isotopes of elements? Are they common? Proton, electron, atomic, proton, electron, atomic number, mass number. What is not common? Mass number. Tomorrow they can change it to neutron. What is not common there? Neutron. I think they will ask you a phenomenon whereby an atom has the same atomic number and the same mass number is that, and they don't do that again. The question is now dated. They will now use another phrase to ask a question. Go and check now. You know it, but the question will look to you. You don't know it. You see question that you know. You start, you read again. You say, you read, you don't understand. You are wasting time. You come back again, it's still confusing. And then you come back the third time, you just choose anything. Please don't write as if you had to be very sure. You have to be very, very what? Sure of the answer. Now, let me tell you, the world now is highly competitive. All this is too competitive, as in, especially those that want to study medicine. Everybody now wants to study medicine. Everybody. So if you're going there, you must displace somebody. You must displace somebody. You must cost 340 and above. 340 and above. Because if you were 320, so to be on the safe side, can you get away? 340. You get away. 340 you see about na ijegwa you kata number by 8 30 by 2 gochefo isa weba. You do it every day until you write jump. You're supposed to have started doing it last year. So if you just started this year, start coming to lesson this year, you're not doing this kind of thing, this kind of stressing yourself like this. Even church, don't go to church. I think I told you last time. Don't even go to church again. Those that score 340, they don't go to church during the period. Okay, go to church now, you score 2 something. Choose one. You don't know when did I get lesson on Sunday? I start private class from 8 o'clock on Sunday and end 8 o'clock in the evening. Yes, no one didn't know what was the chance. See, the chance was Sunday. So, but they will not go to church. Say, choose one. They will either choose for me to come, and the child will not go to church. Because I don't know. He's just been going to church all this while. Just for a short period of time. To just get what he wants. Ichi peka jump. Ichi peka jump. Read your textbook 2 times. Recommended textbook. Like new school chemistry. It's supposed to have read that textbook 2 times. I go to summarize here. That is where they get. That is where jump get questions. So those things you see that they will now phrase the word and ask a question and then put options. If you are not reading your textbook and you're not coming to classes to seek better understanding, so when you read the textbook, you understand. If you bring that document, chemistry textbook and read, sometimes why you do read, sometimes you don't understand because you lack understanding. That's why you come here, I dissolve this topic like this. You go back, you read the topic in your textbook, go to the exercises, solve it. Anytime you start solving problems on the exercises, each exercise is after topic up on the each time you start solving exercises and you are doing well in the exercises, you are good to go. Once you read, you go to exercises, start solving exercises on your own. That is the only way to show that you want to go to that topic. You cannot go to that topic. That's why I would like to teach a concept. I will say no, it will not be complete if I did not solve problems associated to that particular topic. That is the only way. So you will not see how the examiner want to exploit you. They're exploiting you. They will exploit you, ask you the question as exploits. Ask you in a way, give you something in the option that will confuse you in the multi-choice. So that not everybody will score. You know how it is. For 1 point something million registered jam and 1 million pass. They will not like it. They will not like it. So you have to beat those few that will make it. And how will you make it? There are some people now that they have finished this textbook many times. They are now waiting for the exam to be tomorrow. And you are here praying that the exam should be postponed so you can knock over. Okay. What am I trying to say in redox? Please, redox reactions are not like any ordinary reactions. In redox reactions, you balance 2 things. You balance the number of atoms both sides of the reaction or both sides of the equation. You also balance the charges. You'll be doing 2 things at the same time. Let me give you an example as case 1. Let's start with case 1. Case 1. balance the redox reaction. Balance the redox reaction below. And states the oxidizing and reducing agents. And states the oxidizing and reducing agents. And states the oxidizing and reducing agents. Okay, let me just give it to you. Now, right. Fe 2 plus Cl 2. Here, Fe 3 plus Cl minus. Okay, check that reaction there again. The reaction or the equation, is it balanced? Check if it is balanced. It is balanced atomically, but it is not balanced ionically. So there is a problem. It is not balanced. If it is only balanced one way and it's not balanced the second way, it is not balanced. It is a way problem. So what do we do now? What do we do? But first of all, let me ask a question before we don't know what to do to balance it. You ask a question that in that reaction, electron flows from which species to the next species. How will electron flow happens? Electron flow from who to who? Is it from ion 2 to chloride ion? Or is it flowing from chloride ion to ion 2? Electron flow from where? Ion 2 to chloride ion. Sorry. Ion 2 to what? Chlorine molecule, please. Sorry. Ion 2 to chlorine. Then when electron flow from this, electron flow means that ion 2 donates electron, oxidize. Chlorine accept electron and then what? Reduce. This is what makes it a redox reaction. In this reaction, there is oxidation and there is what? Reduction. I think I told you before. Any reaction in which oxidation and reduction are going on in the same reaction is redox. But if a reaction happens and oxidation is not happening, reduction is not a redox reaction. Like neutralization reaction is not redox. Anyhow you have to check it, it's not redox. There are some other reactions that are not redox. But majority of chemical reactions are what? Redox. Even organic synthesis are redox reaction. Even so-called combustion, fermentation, they are redox. We don't know. Now watch this now. Watch this. See what I'm going to do. Electron flow. Well, write it down. Electron flows from ion 2. Electron flow from ion 2. Why will electron flow from ion 2? Open brackets. Electron flow from ion 2. Open brackets. Reducing agents. That's why. Reducing agents. We'll close it. To chlorine molecule. Flow from ion 2 to chlorine what? Molecule. Why will it go to chlorine molecule? Open brackets. Oxidizing what? Agents. Full stop. Paragraph. In balancing redox or ionic equation. In balancing redox or ionic equation, comma, the reaction is split into two half cells. The reaction is splits into two half cells. Is split into two half cells. Is split into two half cells. That is oxidation half cell equation. Oxidation half cell equation. Oxidation half cell equation. And then reduction half cell equation. Oxidation half cell equation and what? reduction half cell equation. Let me show you what I mean by that. Let me show you. What is the state of ion in this reaction? +2 because of charged. What is the state of this chlorine? 0 because it's not combined. What is the state of this ion here? +3 and this -1. From here to here, what has happened? Oxidation. From here to here, what has happened? Reduction. So it's redox. The first thing to do in this reaction is to break it into two halves. Bring out oxidation from the equation and balance. Oxidation is what? Fe2 plus to what? Fe3 plus. That is it. The atoms are balanced. How many mole of Fe do you have here? 1. How many here? 1. Total net charge of this one is what? +2. Here is what? +3. That is the problem. The charge here must be what? Balanced. We're checking which side of the equation is more charged. Is it here or here? Go to the side that is more charged. Add free electron. Even though in chemistry, in science, free electron does not what? Exist. But here you add there for a reason. You see, I will show you the reason. At the cost of the reaction, you see the reason why we added it. We'll see the reason now. Let me show you the reason now. How many free electrons are you going to add to balance the reaction both sides? How many? 1. Is 1. 1e plus what? 1e minus. So this can also stand as what? 1. Plus when you go balance. This is total of this electron loss is -1. -1 plus 3. This side is what? +2. Technically and spiritually, this side is what? +2. This is +2, isn't it? Total net charge here is +2. Total net charge here is what? +2. How? +3 minus 1 is what? +2. It's balanced for now, no? You are done with this. This is what? Oxidation. Are you there? Go to reduction. You have what? Cl2, Cl what? -2. Total net charge here is what? 0. Total net charge here is what? -1 times 2, -2. Which one is more charge here? This side. And now minus now. When you have 0 charge, 0 cannot minus. Go to side that is more charge. How many electrons are you going to add there free to balance here? Is plus what? 2e minus. How do I know it's 2? -1 here times 2, -2. -2 plus 0, -2. This is also what? -2. Technically, spiritually, atomically, ionically, this equation is what? Balance. What is this equation? This is what? Reduction. Are you with me? We're now seeing what to show that free electron does not exist. Electron that was lost here and that was gained here, are they the same? They must be the same. Because in this case they're not the same. What do you do to make sure that the electron here become constant, become same? You cross multiply them. In fact, multiply this side by what? 2. Multiply this side by what? 1. 2 times this, 2Fe, 2 plus. 2 times this, 2Fe, 3 plus. 2 times this, 2e minus. Do the same thing down. 1 times this, 2e minus, plus 1 times this, Cl2, then this is what? 2Cl minus. To show those 3 electrons at the point where electron gain is equal to electron loss, at this juncture, we can now what? Cancellate. And then join the 2 half cells together. What do we have? We have what? 2Fe, 2 plus what? Cl2 equals to what? 2Fe, 3 plus what? 2Cl minus. Let's check if it is balanced. Here is what? 2 times plus 2 plus 0 equals to 2 times plus 3 plus 2 times minus what? 1. 2 times 2 plus 4 plus 0 equals to 2 times this plus 6 plus what? Sorry? Minus what? 2. This is what? Plus 4. This is what? Plus 4. Equation now is atomically and what? Ionically what? Balanced. You just weak. to start. So I say, is there no any happier way? I don't know what you see. I'll give you the happier way, but I don't like happier ways. Okay, now to know if you really are catching up from this, try and see if you can balance this one. Cu 2 plus Al. Here, Cu plus Al 3 plus. To see if you are catching up. Fast. Okay, yes. I'm finished. This is for you to try yourself. And then after you balance, you state which one is oxidizing in the reaction and which one is reducing in the reaction. Okay. Yes. Let me see. Correct. Yes. Have we finished? Huh? Correct. Yes. You are still waiting to copy it from the board. Yes. Are you finished? Correct. No worry, Ned. Correct. It's on your name. Yes. Correct. Okay. The happier way, without going through the process, the charge on aluminium is what? 3. The charge on copper is what? 2. Exchange it. On your way 2, near 3. On your way 3, near 2. On your way 2, near 3. On your way 3, near 2. Equation is what? Balance. I'm going to move it out here. Over here, you make without going through the stress. Over here. It's not correct. It's correct. Solve it. I'll solve it now. I'm managing my marker. Not to write too much. Eh? It will happen, no? Now, see how it will happen. But you have to be you have to be not only myopic here. Make sure you're also hypermetropic. Difference in the charge here. Because no enka but 2 enka. But enka but 0. Enka but 3 or dig easy. But one enka 2, difference in charge is what? Is 1. What do we now multiply what chlorine now? What is it one now? Then difference multiply. What do you see? You get nothing now. You get it. What was it? 2. You might get careful again now. Only add the 2. 2. That means now that it has one charge, it means that you need how many electrons? 2. Technically, 2 now 1. What do you know? What is it? 2 you get this. I said, from this to this, difference is what? 1. When we get that one now, the balancing is what? These 2 chlorine. Then, this one has valency when combined as what? -1. But uncombined chlorine does not what? Exist. So multiply it by 2 atoms. Again, -2. So what they liberate is 2 what? Charge electron. Was it 2 are liberated? 2 of them are now liberated now. Dash was a ion. 2 to this ion. 2 to this ion. 2 to this one. 2 to this one. It's not what? Balance. Then you are multiplying this one by difference of ion, which is what? 1. Multiply this by 1. This. Multiply this by 1. This. It's not the same thing. It's the same thing. Yes. But if it will confuse you, you have to go to their procedure. This is a way. This is a way. So like I research to find out happy way. There is nothing in chemistry that doesn't have happy way. Yes. Anyone in there can make complex. We have to get happy way. Come on, no one did the intelligent go happy way. Open you make a theater intelligent. Because men came hey, and carbon 1. Now everyone has difference in carbon 1. You and carbon 1, it dies. You have to be very, very meticulous. When it will look so simple is when the charge from here is here to 0 and here to here is also from 0 to 3 or 3 easy. Like I can even give you equation. Very terrible equation. Let's say I have something like copper 2 plus Fe equals to, watch this, Fe 3O2 plus Cu. I think you balance the equation now. At an half. Nenien game, can balance the copper with 2. Sure you know. Plus 2. Root 1 near ion. Sharp. Ion will 3. Or 3 near copper. For copper kita, day 3. For iron kita, day 2. For iron kita. Chalo. For iron also. Chalo can give me again. Fe. Okay. For iron, day 2. Chalo. I make a mistake. Okay, see me the Fe 2, not 3. Oh, what? 3. That is ion 3. Okay. Oh, my mistake. In an enemy, I can die. I will not feel it. Okay, from Bego. Because Unfunka, day 3. Check in now. Odo never. 3. Balance. Are you with me? Is it a balance? What is there now? Wait. We're getting. Can't feature here. Can't be done easy. We are given this kind of equation and we are asked to balance the reaction. Instead of wasting time, this is trick. Okay, I'll give you 2 tricks. You choose which one you like. First trick. What is the charge on copper? What is the system of copper here? 2. What is that of iron here? 3. Exchange them. We will see 3 iron now near copper. We will see everybody for copper in 3. We will see 2 copper. We see iron. Everybody for iron in the reaction. Give iron what? 2. And what? Imagine 2 ever. Because if they 2 ever, do 2 ever. What can you see? If they 2 ever, in about for 2 is weak. About 2, you check more the balance. It's balance. Oh, here's another one now. Look at another one. O is minus 2. Plus 2. 0. This is plus what? 3. Minus 2. 0. In this reaction, which species has not changed in value of oxidation number? Which one? Oxygen. Remove oxygen. Anyway, you see oxygen, remove it. If I remove oxygen from the reaction, this is now ionic. It becomes Cu. These two now will go out up. Plus, this one will come in as Fe. This one will go like this. Anywhere you see O, remove it. So this becomes what? Fe 3 plus Cu. Use redox reaction to balance this. Wolo 3 adeba, never copper. Wolo 2 adeba, never iron. Equation is what? Balance. In that you go back to equation. Onya and onya bofu. Onya and onya the same. This and this the same. This and this the same. Equation is what? Balance. Does it follow? If at this point you are not following it now, it means you don't need to understand it now. Just take calm. You go to the person to help you. You'll be happy yourself. Why would they know that what you see? If I want to play a pigeon niche. And then, but in fact, it will be very wrong. Say, do you understand? Everybody say yes. I will start checking myself. You know what I mean now? Everybody cannot understand. But the only thing you do is struggle to make sure you follow those that know. Can they follow and not shout? Do you understand? You follow? Yes. I have problem with that. It's better to say, I have said yes. Then the other one say no. Man, I'm problematic. But if everyone understands words, check it very well. None understand. Oh boy. Okay, now. Okay, by the time we now maybe look at more examples, I think it will enter. Let's go to past questions. I have one interesting question here to solve. Take it down. You understand? I'm still balancing. More problems are still coming. More problems are coming. More problems are coming. Then, listen, another long way you can solve is to break it into two. Sure, you know. By breaking it, just like the way I did it here. By breaking it into two, this is Fe. This is what? Fe 3 plus. Okay? This is, I want to balance it this way. Maybe when you know what I'm doing, but this is normal process. Jam syllabus say we should teach. But time I don't know. I can't champion way to cut these things short. This is how you're supposed to do it. This is 0, isn't it? This is what? Plus 3. But it's balanced atomically. Which side has excess charge? This side. Go there and add what? 3e minus. Equal gakupi. Main cause. Go to next one. Next one is what? Cu to what? Sorry, Cu2 plus and Cu. Kebe were more charge. This side. Get back taking it plus 2e minus 2 and 3 Ophiye mba. We cross multiply times here by 2 times by what? 3. 2 times this 2Fe 3 plus what? 6e minus. Because 2 times this or 2 or 3 and then of my 3 times this 6e minus plus 3Cu 2 plus what? 3Cu. Can you cancel now? How many moles of electrons are released during this reaction? How many moles? 6. Cancel. They have been released. So we do what? Cancel. We join the reactions. You have what? 2Fe plus 3Cu 2 plus equals to what? 2Fe 3 plus 3Cu. Equation is what? Balance. Maybe you want to learn the hard way whenever. Okay, take this question down quickly. Are we there? Are we there? Okay. The reaction of zinc. The reaction of zinc with copper 2 ions. The reaction of zinc with copper 2 ions in aqueous solution. In aqueous solution. In aqueous solution can be represented as follows. Can be represented as follows. Can be represented as follows. I repeat the question. The reaction of zinc with copper 2 ions in aqueous solution can be represented as follows. On the board. You're not seeing it? Any mark there? It's on the board. Okay, let me give you options. We need options to answer. First off, which of the following is the most description for this reaction? Which of the following? Which of the following? Which of the following is the most complete description? Which of the following is the most complete description of this reaction? Of this reaction. Option A. Option A. Copper 2 ions. Copper 2 ions are being reduced. Copper 2 ions are being reduced. And zinc is oxidized. That's option A. And zinc is oxidized. Option B. Copper 2 ions and zinc. Copper 2 ions and zinc. Copper 2 ions and zinc. Copper 2 ions and zinc are being reduced. Are being reduced. Are being reduced. Option C. Copper 2 ions and zinc are being oxidized. Copper 2 ions and zinc are being oxidized. And then D. Zinc is being oxidized. Which one is correct? A. A is simple now. Then copper 2 ion is being reduced. Zinc is what? Oxidized. That's the correct description for the reaction. Our question here. Which of the following is not a redox reaction? Which of the following is not a redox reaction? Which of the following is not a redox reaction? Option A. Yes. Answer is what? C correct. How is C correct? Let's check it now. Plus 1 minus 2 plus 3. How can you say plus 5 now? Check now. Minus 2 is minus 4 plus 4. Sum 0. H is plus 1, I is minus 1, isn't it? This is plus 1 minus 2 plus minus 2 plus 2, 0. Check if it's redox. Whenever a species, let's check. Nitrogen is what? 3. But what? 2. Reduce. Iodine is minus 1. Here, 0. Oxidize. So any reaction whereby oxidation and reduction are going on the same time in the same reaction is what? Redox. So that one is redox. Let's check the second one. 0 plus 1 minus 2 plus 6 plus 2 minus 2 plus 6, 0. It does look like this and this oxidize. This and this reduce. Sorry. This to this. Can I say yes? This to this oxidize. This to this is what? Reduce. Option B is redox. Since calcium belongs to group 2, state is what? Plus 2 plus 1 minus 2 plus 4 plus 2 minus 2 plus 4 plus 1 minus 2 minus 2 plus 4. Calcium is the same thing, both sides. Hydrogen is the same thing. Carbon is the same thing. Oxygen is the same thing. There is no increase and what? Decrease. So this is not a redox reaction. So that's one the answer. Check if this one is redox. Minus 2 plus 2. 0 plus 3 minus 2. From here to here is ox. From here to here is what? Red. That's what I say. Take it down. Okay. Is it possible to identify a non-redox reaction because of presence of carbon? Yes, now. You can identify, you can know which one is non-redox reaction. Okay. Maybe is it because of option C? Carbon reacting with oxygen. Carbon reacting with oxygen. Is this a redox reaction? Is this a redox reaction? What do you call this type of reaction? Oxidation. Abi? all redox now. Then here, 0 plus 4 minus 2, 0. Redox. From here to here, red. Sorry, ox. Here, red. Even when you have, check if this one is redox. CH4, methane, plus O2 equals to CO2 plus H2O. What type of reaction is this? Combustion. Is it redox? Yes. How is it redox? Plus 1 minus 4. Do you get it? Do you get what I just did? 0 plus 4 minus 2 plus 1 minus 2. From here to here is what? Is what? Red. Yes. Is what? Ox. From here to here is what? Red. So it's redox reaction. So what it means that this reaction, what type of reaction is this? Decomposition. So what it means that it does look like decomposition reaction. Are they redox or non-redox reaction? Non-redox. But not all of them. Are together with what? Double decomposition. Yes. How is explain? Oyedele yabira lesson number Wednesday. You want to understand by force. We know what to do. We know what to do for you. Okay. He said, just say, I should calm down, I'm too fast. Am I too fast? Oh, yeah, I'll be a lesson on Wednesday. How much money I'll be a lesson? Oh, do Ajiga, Jumano, we better a lesson. I don't want to get a lesson Wednesday. You want what you got water? If me say my next lesson, better next lesson. If I want to get water. Because so I continues now. Where I stop, I'll continue from there. So let me start from this writer. Uncle, how is HNO3? HNO3. NO2. Okay, tell them the numbers. Oh, you have to come numbers and you know. Plus 1, plus 3, minus 2, plus 2, minus 2. Osisium, Uncle, please explain again. The explanation is there now. It's not there. That's sum of this minus 2 times how many atoms ever? 3. Oxidation number of oxygen in a combined state is what? Minus 2. What times it with, you have minus what? 6. The algebraic sum of oxidation number of all the atoms of element in a compound is what? 0. It's 0 now. Okay, oh, they're on plus 5, not plus 3, sorry. Plus 5. Well, this plus this is what? Plus 6. Plus 6 minus 6 is what? That is why. The same thing is here. Plus 4. Why? Minus 2 is oxygen. How many atoms? 2 times you have what? Minus 4. So this is question mark. But with this now, you cannot know what question mark will be. Plus 4. And this will even help to give the IUPAC names. If I want to name this now, how do I name this inorganic compound? How can you say hydrogen? It's an acid now. And it's an acid that referred to as what? What do you call this? Acids. Acid that contains oxygen. When you want to name them, you don't name by writing or naming the hydrogen. Hydrogen is omitted for acids. So how will I name this? Trioxonitrate 5 acid. How will I name this one? Hydrochloric what? I think you know why the hydro is coming in there. Because it's not an oxy acid. No, the also said that you cannot name hydrogen again. It will now become oxochlorate 1 acid. How now? Plus 1 minus 2. This one is what? 1. Some must be 0. Take note now. Omit it. What is this one? A strong acid. Name. Tetraoxochlorate 7. Number 7 now. Nenianu. Minus 2 times 4 minus 8. This is what? Plus 1. This is what? Question mark. What is the 7 self? 7. 7 plus 1. 8 minus 8. 7. Una calculation. Here jam multi-choice. What is the oxidation number of S in H2SO4? Don't solve it. Rule for combined hydrogen plus 1. Up 10 day 2. Nka minus 2. Up to day 8. Okay? What will be here? If you add this side, you minus this side. 6. Sulfur is 6. Hydrogen. Tetraoxosulfate 6 acid. How is carbon plus 4? Solve onion. Hey, onion, who's going? Can I make a question mark? 2 plus 1 minus 2 times 3 minus 6. There minus 6, kita. Eba bone 3. I've got 3 here. I've got 3 there. Okay, in this case, I'm only add 2. You know it goes the other way around, Abi. Also, here now, CaHCO3 bracket 2 equals to what? 0. This is plus 2 now. Share plus 2 plus only I can say 2 because 2 got multiply here. Okay, so I got opposite plus 2 up here. Plus 2 is plus 1, but this 2 makes it plus 2. This carbon become plus 2x plus you got times no nyan. When you get 6 now, then minus what? 2 equals to 0. Share well plus 2 up here plus 2 again plus what? 2x minus what? 12 equals to what? 0. Up here plus 4 plus 2x minus 12 equals to 0. So 2x equals to what? Minus 12 plus 4. 2x is what? Minus 4 plus... Oh, it's plus. Correct. Plus 12 minus 4. Divide both sides now. If you get now. If you can you know now. You can see why I touch it first was. Please stop learning the hard way. Look way this is not the first. Look at my job now. Look at everybody buys it now. How can you balance this if you only balance alone? If you only concussion. Oh yeah, talk and never. How are you? In a metable period, 4 hours. This your telencephalon. I could remember telencephalon. You know what is telencephalon? You don't know. You better don't know. Okay. Somebody is just going here. Yes, it's a nice balance earlier. Ever can never get in cause of what I am motor. Zinka. So please balance H2SO4 using your method. How can I balance H2SO4? Okay, I can balance it. I know what the question is. It is between H. You treat this as 1. As 1. As what? 1. Solve for highest oxidation number. Because the sulfur belongs to group 6. Its highest oxidation number is 6. Then here, only about 6. Only minus 2. Minus 2 times 4, minus 8. Minus 8 plus 6, minus 2. Total charge when they are going to be together, when they combine, this is plus 1 minus 2 equals to 0. Is it correct? 4 Gisea. Is correct, Abi? This 2 has affected this man. So this is H2SO4 equals to what? 0. Does it follow? That is what the person. Oh yeah, can mean, but I'm not going to present. Tell me. So balance H2SO4. Okay. One more question before I go. Which one? Is this one? And I say, hey, I'm up here. Okay. What's this here? Plus 6. This is what? Plus 3. This is what? Plus 2. Plus what? 7. Okay? Then can say what any or is what? People should not be allowing me to be solving this thing now. You know why this one is 6. But solve it now. Equate everything by minus 2. Find chromium. Do it now so I know that you know it. I think it's correct. Hey now. Can you make root plus 2? Never. Okay, the simple now. Minus 2 times 4 is minus 8. Minus 8 plus 7 is minus 1. Share? Plus 3. Why you just assign is to know which one has reduced and which one has what? Oxidized. Reduced. And what? Oxidized. Let me start with oxidation. Cr2 O7 2 minus. Oh, you idiots. You know why? Because I need to take you step by step. So you understand A, so you cannot go to B. Now, in a redox reaction like this, if you look at this, you find that there is no species of oxygen at the product, have you? Now. This is 2 aqua balance. How do you balance O in this kind of situation? This is where you add a molecule of water, isn't it? In a balance redox reaction, Fukuanara oxoanion as the reactant. Get Monte. Get Kukita oxo. Remember oxoanion. A molecule that contains what? Oxygen. Namely an oxoanion. How do you balance the 7 atoms of oxygen in that molecule? Add molecule of what? Water. How many molecule of water do you think I can add to compensate the oxygen atom? How many am I putting here? Plus 7 H2O. Balance going to be 7 H2O. Protonate. Give me protonation. Hydrogen ion. Protonation. You don't know why you're protonating. Really, you are protonating because you're trying to acidify. Why will I acidify? Inanya, HRD HRD. How many H is here in this water? 14. Come here. Protonate by what? Adding 14 H plus is way cool. Check the atom. How many atoms of H is here? How many here? How many O? How many O? CR. Let's check the charge. How many charge is here? Plus 1 times 14. Plus 14. Plus 14 minus 2. Plus 12. 2 times plus what? 12. Let's check if we can have plus 12 here. Plus 3 times 2. Plus 6. Everything in water is 0, isn't it? 0 times 7 is what? 0. This charge is it equal? Which side is excess charge? This side. Go there, add the electrons. Add the electrons, go to the excess charge. About 6. What number of electrons am I going to add here to bring this thing down? Plus 1. 6E minus. Let's check again. Minus 1 times 6. Minus 6 plus 14. Minus 6 plus 14. Plus 1. Plus 8 minus 2. Minus 1 times what? 6 plus 14 plus 1 plus what? Minus 2. Okay? Equals to 2 times plus 3 plus 7 times what? 0. Minus 1 times 6 what? Minus 6 plus 14 minus 2 equals to what? Plus 6 plus what? 0. Minus 6 plus 14. How can minus 6 plus 8 plus 8? Plus 8 minus 2 plus 6 equals to what? Equals is what? balance. I have balance. Wait, what? Even cause is it time? Uncle, why? Oh, so why? What the why had it? Okay, or slash yeah. So how? Is or slash yeah. How is 7H2O 0? How will 7H2O not be 0? What is the last rule? The algebraic sum of position state of all the atoms of element in a compound or molecule is what? That is why. If you ask me why again, I will ask you why not. In this same case, you do the same thing. You do what? The same thing. When you do the same thing there, let me show you. Amen. I watch. This is what? Mn 04 minus. Where are we adding the water? Where? Okay, 2 plus. Where are we adding the water? There or here? Everybody deficient can I add? How many there? Plus 4H because of this, have we? How many are you portraying here? 8. H plus up here. I'm going to check how many electrons. Check electrons. Check electrons. Check. Everything is balanced here, Abi. 8, 8, 4, 4, 1, 1, Abi. Check total charge. Here is what? Plus 2. Up here. Here is minus 1 up here. Minus 1 plus 8. Plus 7. Get the difference of charge in both sides. Where are you going to write the 5? Is it here or here? Everybody more charge up here. Add what? Plus 5E minus. Check if the charges are now balanced. Check if it's balanced now. This is 2 up here. Minus 1 plus 8 is what? Plus 7. Or plus 7. Plus 7 up here. Plus 7 minus 5. Plus 2. What is this? Plus 2. Electron loss. Electron gain of here. What do? Cross multiply. Okay. Wolunka times yanka. Wolunka times yanka. Okay, what about this here? 6. Well, let's go. Let's start with this. This is going to be what? 5 times is what? 30E minus. Plus what? Nekun. Kyogabu. 70 H plus up here. Plus what? 5Cr2O72 minus. Up here? Okay, also. 10Cr3 plus what? H2 what? O. Up here? But me can cause. Come on now. Here, Abi. 24 what? H2O plus what? 6Mn2 plus equals to what? 6MnO4 minus plus what? 48H plus what? 30E what? Now we're going to now, in anya, if you that now, you whatever. Well, whatever, yeah? Kenkeka 35. Because in Kekan, a bank I get the water. Water man, not to summarize the reaction now. Then check kilumu. HD bro, akuya. Kenkeka. You will now bring this one here. And you put on water there about get up minus. Sure you know. You put on cap plus. Well, let's go. See what I'm going to do now. So what I'm going to do now. I will start with this. 6Mn2 plus akuya plus 5Cr2O72 minus akuya plus 70 H plus Akuya. If this one cross over this side of minus 48 H plus equals to Abogum Sidenka 10 CR3 plus Abi plus 6 MNO4 minus plus 35 H2O minus 24 H2O. Well, let's see. Summarily, we have what? This final answer. 6Mn2 plus 5Cr2O72 minus plus 70 minus 48. Ne equals so can you? Only 22 what? H plus equals to 10Cr3 plus 6MnO4 minus plus plus what? 11 what? H2O. Check if it's balanced. How many Mn? How many Mn? How many Cr2? 10. How many here? 10. How many oxygen there? 5 times 7. Only? How many oxygen there? 5 times 7. I'm going to check here. 6 times 4. Plus 11. Another balance. H never. Check your charge. 9. 6 times plus 2. You put it as times 5 minus 2 plus 22 plus wrong, but can solve already. Plus 1 equals to 10 times plus 3 plus 6 times minus 1 plus 11 times what? 0. Hey, plus what? Plus 12 plus minus 10 plus 22 equals to what? Plus what? Plus 30 minus what? 6 plus what? 0. Plus 12 minus 10. Eh? Plus 2. Plus 2 plus 22. Plus what? Open the 25 by a man and happens here next time. It's 84. 30 minus 2. 24 plus 0. So, I said the question now. I wanted to curse you, but let me not leave you. Please, don't worry, don't bother. I know you don't understand, but I just want to prove something. Next time, this is the kind of problem we'll be solving now. Why not now? It's here now. It's in the past question. It's in the past question. Which one is no? You, I will do it. You. Uncle, please use shorter. Okay, maybe next time I use short. I shorten it. Please, I think I have to call it words a day. Thank you very much.